Alright guys, we're going to talk about programming languages today. Um, today we're going to talk specifically about two types of program languages, high and low level languages. We're going to talk about what are the benefits and disadvantages of each of these languages. We're going to talk about how these languages work and when do we use each language. Alright, so without further ado, let's jump straight in. So first, before we talk about this chapter, we have to first understand what is a program language. So this chapter, small unit, is all about program languages. So what are program languages? We hear this term a lot in our lives, but have you ever thought about what it actually means? Well, we talked a little bit about computer programs before, right? They are a set of instructions that the computer carries out to meet a certain purpose. For example, we have these apps on our computers, on our tablets, on our phones. These are all called computer programs, these apps, right? Now, have you ever thought, how are computer programs made, right? How does the computer suddenly have these computer programs? Now, these computer programs are written and coded using a program language. And programmers use program languages to write computer programs. So that is the purpose of program languages, and that is to write computer programs. Now, there are two types of program languages that we're going to take a look at in this class, and they are high-level and low-level languages. Now, there are some differences between these two languages, and there are three main problems that we're going to take a look at, and we're going to hopefully answer in this unit. First, what are high-level, low-level languages? So what are the differences? Second, what are some of the advantages and disadvantages of using high-level or low-level languages? What are the goods or bads of each language, and when to use each? And lastly, we're going to take a look at what are interpreters and compilers. All right, so with these questions in mind, let's take a look at our first question. So high-level languages. This is what we're going to talk about first. Now, high-level languages are program languages that are very close to English. For example, if you take a look at this piece of code on the right here, it is an example of a high-level language. It's Python. Now, a lot of the things that you see are very similar to English. Like import, we see that English as, color, begin, counter, while. All of these are actually very, very similar to English, even just English. So high-level languages are, program languages are basically like the languages that we use. So what are the advantages of using such a language, that are, so similar to English? Now, first, it is really easy to write and understand, right? And because it is easy to write and understand, it's also easy to debug. And the reason why it is easy to debug means, if I write a program and, some parts of it does not work, I need to solve like the part that does not work. I gotta solve problems in the code, right? So that is called debugging. That is solving problems in your code. The reason why it is easy to solve problems in a high-level language is because it is easy to understand. It is easy to understand what you have written and see the issues you have made in your code. So it is easy to debug. And the last one is kind of weird, and it is that it is portable. So for example, for a high-level language such as Python, if I can install like Python on lots of different types of hardware. I can use Python on a computer, I can use Python on my tablet, I can use Python on my phone, I can use it on all of these. But for a low-level language, and we're going to talk about this in detail later, if I use a low-level language on a computer, it is specific to that laptop. I use this language for this computer. The same language can't be applied to my tablet, my phone, or other computers. But for Python, I can use it on any kind of, device. It all works. It is not hardware specific. So if they ask you list three advantages of high-level languages, they'll write first, it is easy to write and understand. Second, it is easy to debug. And third, it is portable. This is very important. Second one is the disadvantages. So we talked about how it is so easy to write and use, it is portable as well. But what are the disadvantages of it? And the first is that it is inefficient. These high-level languages that are very close to English, that are easy to write, they don't run as fast, right? They don't run at a very fast pace. For example, I have a long piece of high-level code, high-level language code, I may need to run for hours, right? It doesn't run as fast. It is inefficient. And the second is that cannot access or use memory directly. And the reason why I can't do this is because it is not hardware specific. This is a little abstract, so I'll try to explain it the best I can. But we know that we can use Python on our computers, on our tablets, on our phones, or other computers. We can use it on all of these, right? And the reason why it is not hardware specific and we can use it on any kind of device, different devices, is because this language uses some other things, a medium to access the memory, right? But for low-level languages that are only specific to one device, it can access memory directly and does not need that medium. So high-level languages cannot actually access and use memory directly. And this contributes to why it is inefficient. Because it cannot access or use memory directly, it makes it inefficient. The third is that it needs to wait for translation. Now, we're going to talk about this in detail later, but just for now, keep that in mind. All right, so these are the advantages and disadvantages of high-level languages. The advantages are pretty straightforward, but disadvantages are quite abstract. But don't worry, we'll go into the details a bit later about some of the disadvantages. But for now, let's take a look at this thing called an IDE, an Integrated Development Environment. Now, what is this, you may ask? It is a very big phrase, but don't worry, it's nothing scary. It's just a software. You know what software is? Just some sort of just don't care about what software is. It is some sort of like an assistant, like a software which provides useful functions to programmers when writing programs. So it's basically like an assistant to programmers. So some of the useful functions that IDE provides for programmers, like it can autocorrect for you, can autocomplete for you, it can color command words for you. So it's just an assistant, for programmers. This definition is quite important. You can, remember this. And lots of high level languages use this thing called IDE because it, having an IDE makes programming a lot easier because, it provides a lot of useful functions to you. All right, so that's an IDE. Now let's take a look at translators, right? We talked about how high level languages needed translations, needs to wait for translations, and that is a disadvantage for high level languages. And the reason why, and what is translations? So let's first talk about what is translations. So computers can actually only understand zeros and ones. It can only understand binary data. It cannot understand anything else. So high-level languages are written in something very similar to English, right? So if it is similar to English, the computer can't understand it. It can't understand the program or code you have just written because it can only understand zeros and ones. So in order for the computer to understand the code you have written, you need this sort of a translator, a translation. You need to translate the code you have written that is similar to English to zeros and ones, which is machine code. And that is the program that the computer can understand. You need this sort of a translator to convert your code from, this thing similar to English into zeros and ones. There are two types of translators that we are going to look at in detail. First are interpreters, and the second is compilers. They're a little different in nature. And we're going to look at detail on these two as well. They're very important. But for now, just note that, translators are used for high-level languages to convert them into zeros and ones because the computer can't understand, the code that is similar to English. It can only understand zeros and ones. So that's why we need translators. So this is why it is an disadvantage of high-level languages, and that is you need to wait for translation because the computer cannot just straight off understand what you have written over here. It needs to convert all of this to zeros and ones, then they can understand it. So this is a disadvantage. All right, now let's take a look at interpreters. So interpreters is a way in which you can translate. It's like a translator that translates the code you have written from, these words into zeros and ones. So now let's take a look at how it translates your code. And this is a very, very important thing. Appears a lot on exams, and you have to remember this procedure, but you also have to understand this procedure. It's quite simple, actually. So how an interpreter translates your code is it goes like this. It translates the program line by line. So what does that mean? For example, the interpreter receives this piece of code on the right here. First, it translates this first line into zeros and ones, right? It translates this code into zeros and ones, right? Next, what it does is after it translates to zeros and ones, it gives this zeros and ones code to the device, to the computer, and the computer executes this line of code. So the interpreter translates this into zeros and ones, and then the computer executes it. Then it moves on to the next line, translates the next line, and then executes the next line again. And then it moves to the next line, translates, executes, next line, translates, executes, next line, translates, executes until it finishes. So it translates the program line by line, right? Line by line, each line by each line. And then each line is executed directly after it is translated, right? Translated line is executed directly. And then what it does is, because it goes line by line, right? It translates each program, each line of code line by line. So whenever it finds like an error, for example, this line has some sort of error in this second line here. It finds an error in this second line, it will report the error once it is found. So I executed the first line, I move on to the next one, I find an error, I just report the error, and I stop moving on to the next line. So it reports an error once it is found. And it needs source code. This is not really important. Don't care about that. But so it reports error once it is found. So these three are very, very important. It's the key essence to interpreters, and it is first translates program line by line, translated line is executed directly, and it reports an error once one is found. Right? So that is interpreters, how it works. Now there are two traits of interpreters, and as first it runs very slowly. And the reason why is, I can't execute this line directly. I have to translate it, then execute it, translate it, then execute it. So it basically doubled the amount of workload for the computer. You have to translate it first, then execute it. So it runs incredibly slowly. And no executable file is produced. An executable file is basically, after I translate this entire piece of code, sometimes I will create like a file, and this file contains the entire translated code, the zeros and ones of this code, an executable file. And if I just click the file, it will execute and will run. No need for translation anymore. No executable file for this for interpreters are produced. It just translates, then executes, translates, then executes. So it is incredibly slow. No executable file is produced. So you might ask, why do we use this interpreters? And if it runs so slowly, it doubles the amount of workload, right? No executable file is produced. So bad, then why are we using this thing called interpreters? Now, the reason why we use it is when we write programs, right? When we are developing or writing a program, we may make like a lot of mistakes. We may have like a lot of bugs in our program. So when this happens, if we have an interpreter which finds errors, reports an error once it is found, so reports errors incredibly quickly, right? Once it is found, it reports an error, right? It is extremely helpful because it finds errors quickly, right? So um, for interpreters, it is mostly used when you write or develop programs. You can use it because it finds errors extremely quickly. All right, so that is interpreters. Uh, so here you have to remember how it translates these three key traits. Remember that it runs slowly and no executable file produced after it is ran, and that is it is used to develop and write programs because it finds errors quickly. Now let's take a look at compilers. Now, um, compilers are a little different than interpreters. Instead of going and translating the program line by line, right? I translate, execute. What it does is that it translates the entire program in one go. It just takes this entire thing, change it into zeros and ones, and it produces a file containing the translated code. So an executable file is produced. It creates also a new file that produces a list of all the errors in the entire code. And there is no need for source code. Don't care about that. But, right, it translates this entire program in one go instead of going line by line. It creates an executable file and produces a list of all the errors instead of reporting an error immediately after it is found. So because after it is translated in one go, you have like a translated piece, that is, you know, um, translated executable file. This executable file runs extremely quickly. You can say that it runs quickly after compilation, which compilation just is synonym for translation. So it runs quickly after translation, right? The reason why is because it creates an executable file. This file, it does not need any translation anymore. It doesn't need to wait for it. So this executable file runs extremely quickly, way faster than if you have to use like an interpreter. But it is slow before compilation because you still need to translate this entire piece of code, right? Now the problem with this thing is that when you write programs, it is a bit hard to use, right? You need to wait for the entire compilation before you can see the list of all errors. But for interpreters, you can just see the errors immediately after it is found. So it is not as useful for developing programs. So when is it used? Now, because it is so quick after you translate it, it is often used for testing, right? So after I translate this entire piece of code into zeros and ones, an executable file is produced. I just use this executable file to test a lot of data. I just put a lot of data into it, and because it runs so quickly, right, it is extremely useful for this kind of testing. So compilers are often used for testing because it runs very quickly after compilation and you can enter a lot of data into it. So that is compilers. Kind of opposites to interpreters. But yeah, so that is translators. There are two types, interpreters and compilers. You have to know kind of the differences between the two. So that's it. Um, That's actually the end for high-level languages. We talked about what they are. We talked about translators. Now we're going to talk about low-level languages. Now, low-level languages are very, very straightforward. We know that the computer can only understand zeros and ones. So low-level languages are just programs written in zeros and ones. For example, this program right here, it's written in zeros and ones. So it is a low-level language, right? So this is a low-level language. Is you cannot understand it. It's in zeros and ones. There is no way for a human to understand what the hell a bunch of zeros and ones means, right? But the advantage for writing in a low-level language, although it is hard to understand, is because it does not need any translations, any sort of all that bullshit. It runs extremely quick, runs very fast, because you don't need to wait for translations. You just, put this entire code and just run it. The second is that it requires less storage area. Just storing zeros and ones, you don't need to store like a bunch of, changing and translators, so it requires a less storage if you were just to write low-level language. And low-level language, this zeros and ones are actually called a thing called machine code. It's called machine code, and it is written in zeros and ones, machine code. So advantages: runs very fast, requires less storage area, and it is a program written in zeros and ones. Now let's take a look at this weird one called assembly language. It is a special type of a low-level language, which means that it is actually not written in zeros and ones. It is a special type. So normal low-level language is machine code, and it is written purely by zeros and ones. Now this is kind of weird. It is not written in binary. It is written in this thing called mnemonics. Mnemonics. Now, this is really important. A lot of the times, the questions will ask, name like one trait of assembly language, or how is assembly language written. You just say is written in mnemonics. And what mnemonics means is abbreviations. So just don't care. Abbreviations is like each word, or like take a look at this piece, RSW or RSRC1. You have no idea what they mean. RSW means some sort of a instruction, and this means some sort of a instruction. So basically it says that mnemonics means each word, or each command word in assembly language represents a sort of instruction or a larger thing. So you can basically say written in like abbreviations or something. So written in mnemonics. And because it is not written in zeros and ones, the computer can't understand it. Also needs a translator. So it's quite strange that it is actually considered as a type of low-level language, but it uses a translator as well. It uses this thing called an assembler that is really similar to that of a compiler. It also translates all the code in one go, translates this entire piece, into zeros and ones, and it produces an executable file as well. So that is assembly language. It's a special type of low-level language. You have to remember it is written in mnemonics, and it uses a translator called the assembler, which is very similar to the compiler. It translates all the code in one go, produces executable file. All right, that's it for today. Hope you learned something. As always, make sure to revise a lot. Just listening to the lecture once will not work. Do lots of problems, and I'll see you next time.